This method?
Yeah.
So basically I just took the derivative of the original function. So this, I think, was the original function. Yeah. And so remember, this has the power of 1 on it. So when we throw it out front, it becomes a 2. X to the 1 minus 1 goes away. And then 1/2, we throw the 2 out front. 2 times 1/2 is 1, so that goes away. And then 2 minus 1 is 1, which is what gives us the 2 plus x. And then we just plugged in the value for x here to get that. I'm actually going to teach you instantaneous velocity by that method since we've done that now. It's kind of the other reason for skipping it yesterday. There's a few things that you won't be able to do because you don't know the rules of it, so I'm just going to do the most basic one. And then next year, once you know all the rules, we can do the harder ones. But we can solve instantaneous velocity the same exact way. And so I'm just going to try to label stuff so that that's all right. Instantaneous velocity. You can kind of see when you go back to look what it is. So I'm going to do number 5, and then I'll just leave the other odd one because there's not an even one that you would know how to do yet. Just because, like I said, with all the rules. So I'm going to do number 5. S of t, so that's our position function, is given by, or is equal to at squared plus 5 at t is equal to 2. So I'm going to take the derivative of this function. We're going to assume a is a number here because t is our variable. So I need to take the derivative of this. So what would the derivative of this piece be, the at squared part?
4t. Wait, 2at.
2at.
I don't know why I just assumed the a was a 2.
I was like 4.
And then what about the 5? What is the derivative of a constant? What did we say that was yesterday? 0. So that part goes away. So then we plug in 2. So we do s prime of 2. So all we're doing is we're plugging in 2 into the derivative. So 2a times 2, and that's going to give us 4a. And so that would be the instantaneous velocity, specifically at this position at time 2. Whatever, minutes, seconds, whatever it is. Let's see, what's next? All right, let's look at 18. So these say to use the limit definition, take basically the what of the derivative, to find, first of all, the slope of the graph of the function at the indicated point, and then an equation of the tangent line. Also, so the equation of the tangent line is going to be, we're going to use, well, it's a lot, but we're going to use what we find as our slope, and we're going to use point slope form. So this is why I emphasize point slope form so much, because it ends up getting used in derivatives all the time. So this is a use the limit definition. Oh, just to label it. So first we are finding the slope at the indicated point. So number 18, we have f of x is equal to 2x minus x squared, and it's going to be at x is equal to 2. So we're finding the limit as x approaches 2 of, and it is, let me see where, I don't know if we ever actually wrote the, I guess we didn't. So it's basically, where did I know I wrote it somewhere. Basically, it is f of x minus f of a over x minus a is pretty much the formula we're using for this. That's what I was trying to find. It's not really explicitly written, it's just kind of, we did it in an example. So this is of 2x minus x squared minus, we plug in 2 into this equation and solve. So 2 times 2 is 4 minus 2 times 2, oh, well, that's nice, is 0, right? 4 minus 4 is 0. Mm-hmm. So we don't even need to write that part. Now, I'm just going to note it there just so that you see it if you go back and you're not like, well, where'd it go? Over x minus 2. So then, obviously that's 0, you can just kind of disregard it. On top, I'm going to see if there's anything I can take out. Well, I'm going to do this in 2 steps, but I normally would do it in 1 so that we see something that I'm trying to show. So the limit as x approaches 2 of, I'm going to take out an x, so x times 2 minus x over x minus 2. Now, your first instinct might be to just cancel the stuff that's in the parentheses and the stuff on the bottom, but that is not what we can't do that because it's a negative x and a positive 2. So any ideas on what I can do so that I would be able to cancel them? Like, is there something else I could take out? I can take out a negative, take out negative 1. So this would be the limit as x approaches 2 of negative x times, excuse me, x minus 2 over x minus 2. And the reason I wrote it like this, I just flipped it so that when I changed the sign, the negative was in the middle. So then that cancels. So the limit as x approaches 2 of negative x would just be equal to negative 2. So this is the slope, which will end up being my slope of my tangent line. Okay, so that's part A. Part B wants the equation of the tangent line at the point. So what do I need to be able to use point slope form? Like what things do I have to know to be able to do that? I have to know slope.
And then the y, right?
The y-intercept.
Well, point slope form implies that I need a slope and a point. Yes, thank you. Okay, but they have only given me the x coordinate. Okay, I don't actually have a whole point in the sense that I visually see it. However, I can plug 2 into this equation and solve it and get my y value, which we've already technically found because that was f of a is equal to y. Okay. So my point is, well, let's do this. Slope is negative 2. X was given to us to be 2. Yes. So y was 0 by plugging it in to our original f of x. And that ended up being 0. We already found that.
Yeah.
Okay, so I have the point 2, 0, and the slope of negative 2. So does anybody remember what the equation of point slope form generically is?
It's
it's like
It'll be your best friend next year if it's not now.
y1 minus y2. Okay, yeah. Y equals
No, you are kind of on the right track. You took the wrong subscripts on them, but
y2 minus. Oh wait, no.
Y minus
Yeah, you
y1.
got it. Bacon.
yep. Y minus y1 is equal to.
To slope times x minus x1.
Yep.
Good job.
So this is point slope form. In calculus, that will be your best friend. Kind of like the unit circle has been your best friend the last 2 years. You know, especially with trig. It's gotten you through a lot. Point slope's going to get you through a lot in calculus.
Yeah, it's like a love-hate relationship.
It really is. Yeah.
Like, thank you, but I don't like you.
So then we just plug it in. So y minus 0 is equal to negative 2 times x minus 2. So y is equal to negative 2x plus 4. And obviously if there was something with y, we'd actually have to move it over. But now, something that you will see a lot, I think I kind of mentioned this before. I want to say it's our calculus book. Pretty sure it's the book that does it. They actually write point slope form like this.
Oh, okay. So you don't have to move it over.
So you don't have to move it over. And they take either like a lot of those problems will say like write the equation of the tangent line in point slope form. I take it either way, but you're like the answers in the book look like this. So it's just so that you see it. It's the same thing. It might be this book that does it. I don't honestly remember, but it's been a while since we did point slope in this class. So, but either way would be fine. But if it doesn't specify, then you can also change it to y equals mx plus b. And it didn't specify with this one, so I would just move everything over and get it like that. Now there's a part 3, which is like a sketch the graph, but we're not going to do that. So, let's do another one of those. So these are going to be the same A and B instructions, so I'm not going to write that out again, but 20 is f of x is equal to 1 over, come on now, 1 over x plus 2 at x is equal to 1. So part A, we've got to find the slope. So I'm going to have y'all try to tell me what I need to write.
Okay. I got this. Maybe.
So the limit at x, as x approaches 1.
Oh, I forgot
I
about
got that part.
Yep.
I forgot about that part.
That commonly gets left off, so we got that part.
And then-
1 over x plus 2 minus 1 over 1 plus 2.
Yeah, so I'll just rewrite that as 1/3. Also, that means that y is going to be equal to what? I'm pausing for a second. Y is going to be equal to what for my part B? If this is if this is 1/3, it's going to be.
1/3.
Wasn't trying to make it a trick question.
I know.
I'm just like, while you're there, you might as well go ahead and do it. You've already done the math for it. You might as well go ahead and write it down so you have it. Over
1. Wait. X minus 1.
Now what?
Now we can math.
Oh, excellent.
Yep, how would I do that?
And this is
Multiply
x.
x plus 2 by through the x plus 2 over.
Yep, perfect. So then I'm going to go ahead and combine that as one fraction on top to save a step. So this is 3 minus x minus 2, because remember the negative goes to the whole thing, over I'm going to leave this for the moment as 3 times x plus 2, just in case.
Right.
Oh, yeah, thanks. All over x minus 1. I'll think about it. Alright, so then we have the limit as x approaches 1 of 1 minus x over, oh yes, this is nice, 3 times x plus 2. I'm going to go ahead and rewrite this as multiplication of 1 over x minus 1. Do we see why I did that?
I do.
Okay. But, am I done yet?
I don't even know if you just do that.
So if you're just so like if you have a fraction, it's being divided by something, or like in general, division is like multiplying by a fraction. So I just am rewriting it as a fraction to be able to multiply it and to see it better without having to do a million steps. So what do I need to do to be able to cancel something? Because right now, still as it stands, if I plug in 1, I'm going to have a 0 on the denominator.
Gotta take out a negative.
I'm going to take out the negative here. Now, just to save a step, I'm going to write it, I'm going to cross this out and write it as negative x minus 1, like that. Which is more than fine if you want to do that. Or, I mean, if I was doing it on my paper, I might actually straight up erase it. But I don't want to do that in case people need to see it. So now, x minus 1 and x minus 1 cancel. So I have the limit as x approaches 1 of negative 1 over 3 times x plus 2. Now if I plug in 1 to that limit, or 1 for x, what do I get?
Negative 1 over 9.
Negative 1 over 9. So this is my slope. So that's my slope of my tangent line at the point. So now part B. Got y minus y1 is equal to m times x minus x1. So we have y minus 1/3 is equal to negative 1/9 times x minus 1. So in technicality, leaving it like that is an equation of the tangent line in point and slope form. We could change it to y equals mx plus b if we were so inclined, but that's an acceptable answer, so I vote that we leave it.
I vote leave it. It's fractions. I don't like dealing with that.
Now, I don't know what the back of the book has for this. Let me look and see just so that you know. I will accept either on the test unless specified a different way. It's 10.1. Get there one day. There it is. What number was this? 20?
This is just that's just chaos.
Yes.
Okay, perfect. They actually do leave it like this, so we're just going to leave it just like that.
I like that.
So,
Yeah, it's gotten to the point where I have to label all my steps for all my problems because I'm like, I'm gonna look back and be like, what am I writing if I don't?
yeah, no, I get that. I'm trying to go back and see. Okay, we had done 24.
Yeah. 'Cause I think
Let's
we-
look at, I'm going to allow you to use the shortcut since y'all seem to be able to do the shortcut method for the derivatives at a point. You are, I mean, obviously I worked 24 the long way. The long way just takes a long time. So if there's one that you cannot do, like for example, 28, we would have to do the long way. Because you do not know the rules to be able to do it any other way at the moment. Because there's this thing called a chain rule that you don't know. And so it makes it so you couldn't do it.
Okay.
Because basically, if you have, so the problem is 1 over x plus 2, so it's basically what we just had.
Yeah.
You cannot as this sits, take the derivative. So, like, the derivative of this is not, like, 1 over 1. Like, that's not the derivative of that. Like, you have to switch it, and you have to change this to x plus 2 raised to the negative 1. And then you take the derivative the same way, but basically you have to, it's kind of like FOILing. You take the derivative of the outside times the derivative of the inside. Anyways, it's a lot. So you don't know enough to be able to do that. So you would have to do that one the long way. But
Definitely don't.
26 is f of x is equal to x squared minus 3x plus 1 at x is equal to 1. So I will allow you to do this the shortcut way. So we take the derivative of each piece individually. So f prime of x is equal to, so what's the derivative of x squared?
I gotta break the problem down.
Okay.
Is it 2x?
Yep. So throw it out front and take away 1 from the exponent. What about negative 3x?
I'd say it would
So
be
it's 3. Is it 3?
Well, the sign's going to stay with it, yeah.
3.
Yep. I was like, you might be assuming I've already written down the minus sign, but the
Yeah.
sign stays, obviously. But if it's technically, like we had the one yesterday that was like that and we took the derivative, then obviously it's going to cause the sign to change. But
And then
anyways.
plus 0.
Yep, and so we don't have to write that. And so then at the point 1, what we do is we write f prime of 1 is equal to, and then we plug it in. So 2 times 1 minus 3. So 2 minus 3 is negative 1.
I like that a lot better than-
That's a lot shorter, obviously, than the other method. I'm not going to do the long method on 28-1 because I need to get ready to go down in just a minute and help jump rope.
Okay.
I'm waiting on their thing. But I am going to look at I was like, the next section is just says find the derivative, and they have like 1 over x minus 2, and they have it out, and I'm like, how in the world did they get that? They didn't teach that in this section. I'm like, oh, because they did it the long way. So 30, just to get, so this one is just find the derivative. It doesn't give you a point, so we just evaluate it as is f of x is equal to 2 minus 3x squared.
Oh, so you're not like plugging anything in at the end?
Right. So at the end, we're just taking the derivative. So f prime of x is equal to the derivative of 2,
0.
0.
and the derivative of negative 3x squared would be
Negative 6x.
negative 6x.
Oh, we get better doing it.
Dang, I didn't even think about that.
Yeah, no, it just like I just automatically wrote it down. Yesterday I was like, wait, let me moving it in my head. Now I'm like,
Just
oh.
because I'll show you. I would never have you do I would not have you do this part, but I will show you what the chain rule looks like since I have a second with 32, just so you know it won't be like the first time you've ever seen it when you see it next year. So if you have 1 over x minus 2 like that, and you need to take the derivative, we need to rewrite it first as x minus 2 to the negative 1. Okay, now obviously if there was something other than a 1 on top, we have to do that.
Yeah.
So I still follow the same rule. Okay, basically I am just covering this up and I'm taking the derivative of the parentheses. That's basically what's going to happen. So that would make this negative, and then x minus 2. We still subtract 1 from up here, so that gives you negative 2.
So we're taking the derivative of the
So
outside?
I took the derivative of the whole entire parentheses. So basically, I imagined that I completely covered up the parentheses pretty much, and I just said, what's the derivative of that?
Oh.
It's basically what I just did. This is a chain rule. So the chain rule, we start outside, and then we take the derivative of the inside. So now I am taking the derivative of the inside.
Okay.
Okay, so it's the derivative of the whole times the derivative of the inside, which is, we're just looking at the x minus 2. So the derivative of x is
1,
1. The derivative of negative 2 is
0.
0. So it's just times 1. Okay, and I'm just going to write that so that you see that we actually did something. So then, now this would be obviously negative parentheses x minus 2 to the negative 2. I don't like negative exponents, so I'm going to move it back. So I'm going to have negative 1 over x minus 2 squared would be the derivative of that.
Okay.
Okay, so yeah.
So,
That's not
again,
hard.
this would not be on your test. It is not on the test unless I tell you to do the long way. Okay? Unless using long method. I'm going to have you try 28 that's similar to it, that's at a point, using the long method, just so that you get practice with it. You have to do one with the long method, because I doubt off one example you understand the chain rule fully. So if you do and you impress me, well, that's exciting. All right, so then the problems for you are going to be 3, 19, and then, let's see, 25, 28, oh, come back. 28 is the one I want you to do the long method on. The other ones you can use the short method. And then 29 and 31. So some of those are literally just, like the last two are literally just finding the derivative. And then 19 and 25, well, 19 is the slope problem, so it's a little long, but anyways, it shouldn't take you super, super long time to do them.